Hello grade 12s, welcome back into this series of videos provided by Dubsmath. In this lesson, we'll be looking at probability revision, in particular the counting principle, which is one section that most students, they always complain about. So we'll try to just look at some of the common exam type questions from past papers. And then if you look at this topic, it has very, very few marks, normally less than 10 marks. Yeah, the grade 12 probability, because I think it's 15 marks, the entire probability in your paper. So 15 or 20, yeah. So they can ask it mainly in three ways. So one could be around the word or letter arrangements. So they give you a letter, a name, maybe they say a word, they say probability. Then they ask you how many arrangements can be made from this word, how many letter arrangements can be made, meaning that you can construct different words by just changing letters or swapping letters around. Like you can choose to start with a B and then followed by a P. Yes, so we don't have the other P now, so it would look like this. So that is still an arrangement, a different arrangement. So you can arrange the letters in many different ways. A simple way to think about this is that you can just keep on changing the first letter. Start with a P, start with the R, start with an O, and just keep on moving your letters like that. But there are so many different ways that can be done. And then that's one way they can ask you. And then the other one is if they ask you to create a code, they say maybe you're creating a 5 characters code or password, maybe a Facebook password. They say it has to be 5 characters. So 1, 2, 3, 4, 5. Maybe the first 3 has to be letters, which our letters are normally A to Z. So you would be having 26 options to choose from. Then they say maybe the last 2 characters has to be numbers or has to be digits. So with digit you can normally use 0 to 9, meaning that you now have 10 options, because you have 0. You don't have 9, but you have 10 because you're also including 0. So you would have 9 if you're starting from 1 to 9, but now we're starting at 0, so we have 10. That's one way. The other one is they say arrange. Maybe we've got 10, we've got maybe 4 people. They have to sit in a taxi, and then maybe this is person A, person B, person C, person D. Then they're gonna say how many sitting arrangements can be made from these people, which would be, you need to think about in the first seat how many people can sit, and then in the second seat, third seat, and fourth seat. As you know, it was a person sits down with, like for example, with the 4 options here, because the 4 people, they're all standing. Once now the first one is set down, we now have 3 people for the second seat. And then the same happens, the 2 people now are sitting down, and now we'll have 2 people who are standing. So we have 2 options now, 2 people who can sit on this third seat. On the last seat, of course, now we only have 1 person standing, so we have 1 option. Then you're going to multiply this out. That's how it would work, which is where there are no restrictions. Then they may tell you, okay, maybe some people have to be grouped or have to sit next to each other, and they can say B and C have to be next to each other, which means that we now treat them as one unit. But again, even within that B and C, it could be BC, or they could sit like this, B and C, as long as they are BC or CP. It could be person B first followed by person C, or person C first followed by person B. So they are still sitting next to each other here. Meaning that even this unit on its own will have 2 factorial arrangements, but this one, if there are no restrictions, it will be 4 factorial. But let's look at the actual questions, starting with word arrangements. We are given a word. Let me just pick let me just use my name. Let's say we are given Tandeni. Yes. Okay, so first question, we're given this word. Before we even look at the questions, just need to understand how many letters does it have, how many are repeated, and all of that stuff. So let's start with that. That should always be your first step when you're given a word. Understand how many letters are there. So if you look at this word, first you can see it has 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 letters, number 1. 2, we look at the repeated letters. So we have 9 letters. Which letters are repeated? So we only have N here. So that N and that N. So we have 2 N's. Okay, we can now move to our first question. Now they're saying how many different unique, actually just how many unique arrangements of letters can be made. So basically, that's how many different weights can we create from this weight called Mtandeni by just rearranging the letters. So the principle there is always going to say the number of, it's going to call it an A, where A stands for arrangements. So number of arrangements without any restrictions. We always say, always going to have a numerator and denominator because we're dealing with letters or weights. So we first look at how many letters do we have. It's 9. So we're going to have 9 factorial. And then why? Because we can, like I said, we can rearrange this. There are 9 positions that we have. So we can rearrange them like that. But now then we need to divide by then, because there are some repeated letters here. So we need to divide by these identical letters, which we only have n. And how many n's do we have? We've got 2 n's. So we're going to divide by 2 factorial. If we had 2 n's and 2 a's, we're going to divide by 2 factorial for n, and then by 2 factorial again for a. If we had 2 n's and 3 a's, we would then say divide again by 3 factorial to account for repeated letters. So you divide by your repeated letters by the number of repeated letters, factorial of that. And then you would calculate this. Then we are getting 181,404. So we're getting 181,440 different arrangements that we can have, or different weights that we can create if we are rearranging this. You can say it's a lot. This should give you some question about Lotto, because even there we have a similar thing, but you're going to see maybe if we do such questions. Now, question number 2, saying determine the probability that the word starts and ends with a vowel. Okay, so it must start with a vowel and end with a vowel. So we know what are the vowels. So we know that vowels are A, E, O, U. The other ones are called the consonants, right? So your B, C, D, and all the way to Z. So how many vowels do we have? We always have 5, but then we'd have how many consonants? So between 6 minus 5, which would be 21, 22. Not 21, yes. Okay, but that's just some context. But now they're saying now they're giving us a condition now. So for number 1, we just said how many words can be formed without any conditions or restrictions. Now the second restriction now is that we must start with and end with a vowel. So we must do this. Let's look at which vowels do we have here. So we've got A, E, and I. We've got those vowels. So our vowels are A, E, and I. Those are our 3 vowels. Now let's start on end with a vowel. So let's look at the first case, which would be, it can start with A and end with E. Fortunately, these vowels are not repeated, so we only have 1 A, 1 E, 1 I. So it is fine. So it must start with A and ends with E, or starts with A and ends with I. Let's do those different cases. Okay, so let's say case 1. So we have got how many slots? We have 9 slots, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So it must start and end with, so we're saying here, starts with E, or starts with A, and then ends with E. So we've got A here, and then we have E here. So that is case 1, meaning that now we have how many letters that are left? We now have, so these are fixed. So A and E, they are fixed. You cannot move them. So if now we are doing our, okay, so I'm not sure if I should split the cases first and then we do the calculations later. Maybe I should do that. Okay, so let's just do the arrangement, different cases. So you can see that's going to start with A and ends with E, but it can also start with, so it can start with E but ends with A, just the opposite of what you have here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're starting with E, ending with A. Okay, another case that we have, it can start with, so we've covered these 2. We're now saying it can start with A, but we're going to look at A and I. So case 3, we're looking at A and I. There it can start with 9, can start with A and ends with I, or it can start with I and then ends with A. So still have 1, 2, 3, 4, 5, 6, 7, 8, 9. But now we have I and A. Hope you can see the pattern now. So we've covered A and E, A and I, now it's E and I. So case 3, E and I. So one can start with E, ends with I. So we still have 1, 2, 3, 4, 5, 6, 7, 8, 9. Starts with E, ends with I, or starts with I, ends with E. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Starts with I, ends with E. Now let's look at the actual probabilities now. So if it starts with A and ends with E, so we're gonna have the numerator we will have, so these two, they are fixed. So we had 9 slots, so we're only left with 7 now slots here that are available, or yes, 7 letters. Maybe just 7 letters are left. So we're gonna have 7 factorial. But now out of the 7, do we have any repeated letters? Let's go back. So we still have n, which is 2 n's. So we're gonna divide by 2 factorial. Can treat these as just being 1 times 1 because they are fixed. Don't even have to, or they have fixed positions. So we are done with this case. But it's going to be the same when it ends with, starts with E and ends with A, because we still have 7 letters that are left, but we have 1 repeated. So 7 factorial over 2 factorial. The same here. You're going to see if we try to reason, we'll get 7 factorial over 2 factorial as well. 7 factorial over 2 factorial. And then even here, 7 factorial over 2 factorial, 7 factorial over 2 factorial. So how many cases do we have? We have 6, obvious, because we can pair that with that, pair it with that, or we can pair it with that. So now let's look at how many total arrangements that we can have here. So total arrangements, we're going to add all of these. So what do we have? We have 7 factorial over 2 factorial. So we're going to be saying that plus that plus that plus that plus that plus that, because those are the all different options. Basically, we're using an O. So when we're using an O, we are adding. So O, saying this, O that, so it's a plus. O this plus, O that plus, O this plus, O that plus. So we have this plus 6 times. So which ends up being 6 times 7 factorial over 2 factorial. But now they wanted in probability. Probability, what do we do? We must say these are a number of arrangements, but I must divide by something. You divide by all the possible arrangements without any conditions, which is what we calculated in 1.1. And for most of the time, it would be what you will be dividing by what you got in 1.1, or in your first question that they would be asking you in an exam. Normally, they break it down like this. So then we say the probability that starting with a vowel will be 6 times 7 factorial over 2 factorial divided by all possible outcomes, which is that 181,440. If you don't know what to do with probability, just always divide by what you got in the first question without any condition.